Okay, so part A says show that dy dx equals minus x plus 1 over 2y to the third plus 1. So to do that, we have to use implicit differentiation. So we have to find the derivative. So it'd be 2x plus 2 plus 4y to the third dy dx plus 4 dy dx equals 0. Now let's take out the dy dx's and group it all together. So it's dy dx parenthesis 4y to the third plus 4 equals negative 2x plus 2. So now let's go ahead and take out a negative 2. So then we get negative 2 x plus 1 all over 4y to the third plus 4. So now let's take out a 4 on the bottom, and we get negative 2 x plus 1 all over 4y to the third plus 1. Now we can cancel those. And now we have the answer. So that's part A. Okay, so part B is really easy. It says write an equation for the line tangent to the curve at the point negative 2, 1. And in part A, they already gave us the slope. So all you really have to do is plug in negative 2 as x and 1 as y into the derivative equation. So we get negative 2 plus 1 all over 2, 1 plus 1. So then that equals 1/4. So that's the slope of our tangent line equation. And then, since they give us a point, we're obviously going to use the point slope method. So it's y minus 1 equals 1/4 x plus 2. In part C, we're asked to find the coordinates of the 2 points on the curve where the line tangent to the curve is vertical. To do this, we have to make the slope of the curve be undefined. And to do that, we have to make the bottom half of the fraction equal 0. The fraction right now is negative x plus 1 over 2y to the third plus 1. So we have to take this and make it equal to 0. So to do that, we basically just get y plus 1 equals 0. It'd be y to the third, but it's the same for these purposes. So y equals negative 1. So now we plug y equals negative 1 into the original equation and solve for x, and you should get 2 points. So now let's plug in y equals negative 1 into the original equation. So it's x squared plus 2x plus negative 1 to the fourth plus 4 times negative 1 equals 5. So we get x squared plus 2x plus 1 minus 4 equals 5. So we get x squared plus 2x minus 3 equals 5. Let's bring that 5 over, so it becomes x squared plus 2x minus 8 equals 0. Now let's factor x plus 4 times x minus 2. So we set those equal to 0. And we get x equals negative 4 and x equals 2. So our points are -4, -1, and 2, -1. Alright, so in part D it says, is it possible for this curve to have a horizontal tangent at points where it intersects the x-axis? So let's always keep in mind the derivative equation. So in previous problems we found what the tangent line actually is. So to have a horizontal tangent line, that means that the numerator has to be equal to 0. So this will happen when x equals -1. But for it to intersect the x-axis, y also has to equal 0. So just in case you don't know what a tangent line is, it's basically a line that is tangent to a point. Let's make up a point right here that's -1, 2, and this line is tangent to it. So what they're asking for is if we can have a horizontal tangent line where it intersects the x-axis. So it's basically like this. And the answer to that question is no, because you have to plug in these numbers into the first equation that they give you, and you get 1 plus 2 times -1 plus 0 equals 5. And I think we both know that -1 does not equal 5. So no, it doesn't work. And that's it. You have completed the 2008 AP Calculus AB Free Response Question number 6, Form B, and you got all 9 points. Good job.